Okay, well, I'm here to give you a little bit of an introductory talk to the Maps API for Flash. Any of you who was at Ware 2.0 a couple of weeks ago, that's when we first launched this. So it's been out for a couple of weeks. We've had a little bit of feedback. Hopefully things are going well so far. We'll certainly try to take account of the feedback and make sure that it continues to improve. I thought I'd start by giving a little bit of an overview of why we've called it the Maps API for Flash, for example. There are a choice of competing names on that. And really, we've done it based on runtime. So Google JavaScript Maps API has been out for many years. That's really the sort of flagship product. If somebody has JavaScript on their machine, all well and good. If they don't, then they have the option of going over to the static Maps API, which just requires HTML. And then with the Flash API, we now have the option for people who have no JavaScript environment still to have a sort of quite interactive experience with the Maps API. In terms of how it's built, there are really two things that a developer needs to obtain. One of them is what's marked in blue here, it's the interface SWIC. That's our developer-facing component of the API. And the other's the Flex SDK, which is downloaded from Adobe. Adobe's recently provided an open source version of that, I believe under the Mozilla public license. So it is possible to do sort of open source implementation of this. The developer takes the interface SWIC, which contains our sort of interfaces for the API, and combines it with their own ActionScript files, processes it through the Flex SDK, out pops a developer SWIF, which they place on their website. And all they really need to do is sort of put that developer SWIF on their website, and they've got a working map, hopefully. Many of our APIs live on code.google.com, and the API for Flash is no exception. So if you go to the Maps documentation Flash directory, there'll be an introductory HTML page which talks you through the process of getting started with this. There's a little tutorial. There's a slightly modified Hello World compared to the one I'm going to present today, and some documentation there too. One of the links there then leads onto this sdk.zip file, which is on maps.googleapis.com. That's the file which the developer downloads. Inside that, there are a couple of directories. One of them is a docs directory, which leads to some ASDoc generated documentation. And the other is a library directory in which we've got this interface SWIC file, which is what you need to compile your programs against. Perhaps show a little bit of example of what the docs look like. I've just put those onto a local server. So that will be the sort of standard Adobe format, showing the different packages inside there, different classes. There's some examples code scattered around that documentation. We're certainly working to improve the number of examples and just sort of make sure that people can really sort of get started and take full advantage of the functionality. When you first create a map, by default it looks very similar to the JavaScript API. So I'm really working on the assumption that some people in the audience will be quite familiar with the JavaScript, so I'll keep sort of trying to point out the differences between the API for Flash, the API for JavaScript, but also really tell you a little bit about some of the advantages I think that the Flash gives us. So we have a set of controls which appear very similar. We have functionality such as info windows, which can be opened, so on and so forth. And then the map is, of course, interactive. When you build a map, you take this interface SWIC, which itself is contained inside the zip file. Inside that, there's then an interface SWIF. So that's the compiled code for the interface which you're programming against, and an XML library catalog. And the XML library catalog provides the definition of classes and the signatures of the methods inside those classes. So that's how the compiler is able to assert at compile time that your code is compiling against the interface and just pick up any type errors at that point. I've shown an example on this presentation which takes one of two possible approaches to building a map. Basically, it's very similar to sort of standard object-oriented choices that you can go between inheritance and encapsulation. So in this case, I've demonstrated inheritance. So we're subclassing class map, which is in com.google.maps namespace, and automatically you get the functionality. If you do go to the documentation website, you'll see an alternative approach, which is based on encapsulation, putting this thing inside a Flex application container. Now, many people have used Flex, will find that much more natural way. I just did want to point out that there are these sort of two approaches you can take, depending on whether or not you want to have all the functionality of the Flex libraries in your application. Those two things go into the MXMLC compiler. Out comes a Swift file, Flash movie. Now, usually a Flash movie would not be accessed directly on a browser, so you wouldn't point a browser at mymap.swift. What's much more common is actually to embed that inside some HTML. You do, however, have the option of just using the Swift if you wish. One thing I should point out, though, is that the Google Maps APIs do require a key, so that's registered against your website, and that needs to get to our servers somehow. So if you compile that into the Swift, you can just use the Swift directly. If you don't compile that into the Swift, you can place the key in the HTML. Pros and cons to both. It's easier to change if it's in the HTML, no recompilations required, but it does mean that, for example, that key's externally visible, sort of very straightforwardly. One of the features which we think is going to be quite beneficial to the Maps API for Flash is the dynamic loading of the implementation library that we've put together. So if you get the initial version of the SWIC, you'll get version 1.1 of the Swift, and you'll connect up to Google servers. And at runtime, so whenever a user starts a map session, it's going to be downloading version 1.1 of the implementation library. Now, over time, we'll be releasing updates, so we find optimizations, bug fixes, and so on. And so the version of the implementation library is going to steadily increase. By default, you're going to get what we regard as the latest version, which is basically that black line on the right coming down from version 1.3 here. But you do have the option, in addition maybe to placing the key inside the HTML, when version 1.4 comes out, you can place a parameter version inside the HTML, and that you can use to specify that you want to get version 1.4. Now, I note that this is at a period in time before we've actually incremented that black line. So Google servers are still telling you the latest version is 1.3, but version 1.4 is live. And that's really intended for developers who want to test out the latest features immediately, rather than waiting for that a little bit longer just till we're that much more confident that everything's stable and all existing websites work. The other thing you can also do is you can step back in time. You can say some features changed in version 1.4. I'm not happy with those. I want to keep locked onto 1.2 because I know how it behaves. The only restriction on that is that you need an implementation library that is at least as recent as the interface library. So when we come up with a new interface library, we might have some new functionality. We need to make sure that the implementation library is able to provide that functionality. Okay, I'll step through a little hello world. In C, it's probably a few lines of code. It's a little bit longer, Maps API for Flash, but not too much more. Those of you who are familiar with JavaScript, if you're seeing ActionScript for the first time, perhaps point out there's some quite significant differences between AS2 and AS3. AS3 is quite similar to Java in a lot of ways, although it does have the same ECMAScript roots as JavaScript does. So you'll see things like types being declared, something which has got package structure, something which has got sort of quite strong sort of class hierarchies built in. When we put together a map, because that implementation library is being downloaded, initially when your page opens, that hasn't yet arrived. And so most of the functionality can be accessed only after you've received the map ready event. So pretty much all applications are going to have this listener waiting for the map ready, and when that's happened, you'll actually start interacting with the map. In this case, setting its center, setting it to be a normal map type so it shows the roads, and setting the zoom level to 14, which is counting more zoomed in from zoom 0, which shows the whole Earth. Another thing you often use is some MXML. There's a lot of flexibility in this. You're free to use just ActionScript, you're free to use just MXML, but often MXML will, for example, contain just a little bit of code to get started, really. You can put the ActionScript inside the MXML if you wish, but I'd defer to Adobe documentation for a lot of those details. You do need to obtain this API key from us, so if you go to this website, there's a sign-up page, and you enter the URL of the website you want to register against it, and it'll provide you with a key. It also gives you a little example of how to build a map in JavaScript. We haven't yet updated that to give you the example of how to build it in Flex. When you actually run the Flex SDK compiler, MXMLC, I've just got a little example of a command line shown here. So I'm pointing at hello-world.mxml, which provides my top-level class. All the other classes are sort of pulled in automatically from that. And I'm pointing at the flash_1_1.swik, which is this interface library. So that just gets pulled in, and the compiler knows the types which are available to your application. A few lines of code get output, at the end of which hopefully it will say something like the name of the SWIF and the size of it, which means compilation is successful. And just at the bottom, I've got a couple of links to some Adobe tutorials on getting started, covering basically the ActionScript 3 language and how to program with ActionScript and MXML. Now, usually I mentioned you place one of these maps inside a web page. If you're going to get it to work with a variety of browsers, then you need both the object and embed tags. So you can see some replicated information inside this, which is really just sort of coping for those two browser environments. It's got the name of the SWIF, in this case hello world, and it's picked out in red also key equals just a dummy key here, A, B, C, D, E, F. Now flash vars is a mechanism by which you can pass in variables to the SWIF when it first starts. So in this case, it's just showing a parameter which illustrates passing the single variable key. You can have multiple ones in there. You just separate them using an ampersand in the same way that you would for URL query parameters. Okay, I better actually sort of show you a working map. So, which hopefully will start up in a few seconds. Okay, so with that few lines of code, you get a map with some basic functionality. So I can do things like drag it around. I've got some smooth panning, for example, keyboard, events work, and so on. But there's sort of really not a whole lot you can do with that map beyond just sort of demonstrating that things are working and your key matches the domain on which it's on. I'll also say that if you're running this from a local hard disk, you're still going to get a functioning map. The only difference is going to be that you're going to see some red messages written over each tile, which just inform you of the fact that it's a debug version. Okay, I've got a little section running through some of the functionality we've got. We've got things split up into packages. So really the base package COM Google Maps provides the important classes to get started. So you'll see inside there is map. There are also some helper classes which provide things like sort of alpha, color, conversion functions, lat longs for geographic locations, an example of projection base, which is something you can subclass yourself, really to sort of extend it. We've aimed to try to make things as extensible as possible. So already we've seen a few examples come back from developers of things we didn't think of doing, but hopefully there's sufficient opportunity to sort of develop what we've provided to really put together some interesting maps. In virtually all cases, you're going to want to put something on top of the map beyond just the standard Google tiles. So a couple of packages, overlays and controls provide for that. If you're familiar with the JavaScript, you'll recognize many of the names from there. So for example, for overlays, we've got the standard ground overlay marker, polygon, polyline, some helper classes such as encoded polyline data. In controls, again, we've got the standard controls and a helper cast control position just to tell you where to put the put the control onto the page. Not everything's visual, so there's also package services, which provides geocoding. That has got a few classes inside relevant to that. And a couple of other packages which are in there. Interfaces is one which we use to provide the separation of interface SWIC and implementation library. So basically, by providing interfaces, you program to an interface, and that ensures that even though we may change the implementation, things will keep working. And then styles is a little bit of a miscellaneous package, which provides a place for us to place things like button styles, which don't really correspond to a single feature on the map. So I'll step through each of those packages just to give you a little bit of a flavor of what you can do with them. So inside maps is cast map, and there's a couple of methods highlighted in bold here, just sort of enable scroll wheel zoom, enable continuous zoom. And again, you see that I'm waiting till I've received the on map ready event before I invoke these. If I invoke a map which has got that code put together, then now I'm able to do things like sort of scroll wheel zoom between different zoom levels. An example of an overlay is a marker. That's probably one of the most common ones. I create a marker. The only requirement is I pass in as the first parameter a lat long, which tells the marker its initial position. That could change if the marker is draggable. And marker is a class which implements iOverlay. An iOverlay is the interface which is required of anything when you call add overlay. So add overlay, you can pass in any of our overlays, and that will put it on the map. In the controls package, this code fragment shows examples of adding the 4 basic controls. I mentioned that there was a base class somewhere in the past, and people have been able to put together customized controls if they need functionality which is not provided by these basic ones. Again, you see the sort of import statements for each of those controls at the top. Often people will use a wildcard there, so it'll just be import com.google.maps.controls.star, for example, just to save space. Might just get the demo up, which just shows some controls being added to the map. So now I've got the ability to change, for example, the map type. There's a little navigator window down here, which I can use to sort of zoom through zoom controls and so on. Geocoding is similar to the JavaScript, but slightly different. So geocoding is accessed through this class client geocoder. That takes a couple of optional parameters. So there's a country code, there's a viewport if you want to restrict the geocoding to that region. Whereas the JavaScript uses callback functions, we use perhaps a more Flash, more flex-oriented approach of adding an event listener on the geocoding object. So you can register events for success or failure. I'm just showing success in this case. When it comes back, there will be a lat long inside that response data, which you can use in this example just to sort of place a marker onto the map. And again, just sort of going to a little demo of what that works. Perhaps not the most convincing one because it's just going to show a essentially hard-coded marker position. That's the Google offices in Sydney. I thought markers might be a sort of reasonable choice of overlay to sort of show some of the advantages that we get from using Flash. Obviously, one of the things you can do with markers is have some form of interaction. So you can add, as shown here, an event listener, which is listening for somebody clicking on the marker. When that happens, an info window opens above it. At the time the info window opens, you can sort of pass in whatever display information you want. But it's perhaps really sort of customization, which is one of the main advantages of using the Maps API for Flash. And this is sort of showing the basis of how some of that's achieved. So as well as that required parameter, the lat long for a marker, there's also a marker options class, which can be used to sort of pass in details customizing the appearance of that marker. And marker options takes an untyped object as its parameter, and using this sort of object to literal syntax, we can have quite a compact form of representation for a lot of flexibility in how these things appear. So for example, there's a compound object which is showing a property fill style, which itself has a property color, which just sets how the markers are shaded. To go a little bit further into marker options, this is just showing the properties inside there, and for each property the type it takes. Just to point out that a lot of the basic types are shown in square brackets, and that's because they're actually defined in terms of being an untyped object. The advantage that gets us is that an untyped object can have the value null, so we can use that to say, I don't want to change this property, I want it to keep its default value. If we had a choice just between Boolean, true and false, whenever we passed in one of these marker objects, we'd always be setting it either to one of those two values. The other thing you'll see is some sort of more compound objects. Those are a combination of some FlashFlex built-in types, shown in grey there. Some of those are Google-defined types. Some of those may then have further sort of embedded objects, and so on. So there can be sort of quite a deep nesting of options and really a lot of opportunity for customization of how things appear. This slide just sort of shows the available styles and options we've got within the API. And the basic pattern is that if there's a class X, there's going to be X options class as well, which is just used to actually configure that. The styles at the top, for example, I can tell you the button style is made up of a few button face styles, which define how the button appears in different button states. The button face styles then contain some text styles. They contain a bevel style, which shows how the bevel is actually sort of shaded on that. And all of these things are customizable. One thing I haven't talked about before is map type options, just buried in the middle. And that's something you'd use if you were going to provide your own custom tiles. One of the things we have to do is pay very careful attention to acknowledging copyright owners inside the map tiles, so data providers. Using map type options, you can pass in your own copyright information relevant to your tiles, not to ours. Customization gets us so far, but there's always going to be a point at which we have to just hold our hands up and say, okay, we can't draw what it is you need, so you draw it and we'll take responsibility for actually placing it on the map. And that's provided through custom markers. So if you hand in a display object, we'll position it. I would stress that we are positioning it. We're not using that display object as a template to stamp out marker icons. So if you want to have two markers, you have to give us a unique display object for each of those markers. We're just going to take responsibility for actually making sure it appears in the right place on the map. And that display object can either be passed to us as is shown here, sort of based on embedding a PNG file at compilation time, and that just creates a class marker image. If people are coming from JavaScript, they might not have sort of seen this approach, but basically marker image is itself a class. When you create an instance of that class, you create a display object which shows that image. The alternative way, obviously, is to actually download the marker image from somewhere, from a URL. So in this case, I'm showing code which is going to pass in a URL to myimage.png. It's going to do something a little bit odd, again, if you're coming from JavaScript, which is that the loader object it uses to load this image is itself a graphical object, a display object. So it can use that loader itself as the marker. And that's actually related to some Flash security issues as to why we do things that way. Pretty much every language on the web has got a lot of security based around the idea of domains. So if you're on the same domain as another program, you've usually got a great deal of access. If you're on a different domain, you tend to have very restricted or no access. And that's true in Flash as well. So I'll give an example of a couple of sites, site y.com and site x.com, and they provide two image files which are available through URLs. In the case of site x.com, they've also provided a cross-domain.xml file, which is allowing access from domain star, or in other words, allowing access from anywhere. And what we can do with those two images is fairly different inside the Maps API. So when you're writing something for developer.com, you're free to load both of these images sort of through a loader object. Flash makes quite a strong distinction though based on what you're then going to do with the image you've loaded. If you want just to display it, you don't need any special privileges. But if you want to dig a little bit deeper, if you want to get access, say, to the pixels inside that icon, then you do need to have security privileges in order to do that. So in this case, with sun.png and storm.png, you could put both of those on a map. But if you want to go a little bit further maybe and, as we do, generate a shadow for storm.png, that shadow is generated by passing that image through a filter, which sort of comes up with a grayscale image used as a shadow. Then you're only going to be able to do that if you've got access to that domain via a cross-domain.xml file. I should also point out as well, there's actually a fourth domain involved here. Because much of the functionality occurs in code which is downloaded at runtime from maps.googleapis.com, that's the domain which actually needs the access. So if sitex.com had chosen to provide access to developer.com, you'd still be running into problems when we tried to auto-generate a shadow inside maps.googleapis. And we catch a security error which happens internally. What you would see is just a silent failure of the marker shadow to appear. Conversely though, of course, this method does allow sitex.com to choose to offer access only to maps.googleapis.com. They've only allowed access to a very restricted domain now, and yet that functionality can be made available to any developer site. So it sort of cuts both ways, and it's just really a choice of what security access people who place resources such as icons onto the web regard as appropriate. And they're just showing those little icons on the right. You might see a shadow behind the storm, but not behind the sun. I mentioned that when you pass in a custom icon, it can be any display object, and that includes Flash movies themselves. So there's a little bit of example code here, which basically puts together a spinning marker. It's comprised of a circle filled, and there's a cross which spins. And there's a couple of event listeners registered, so when you hold the mouse over this marker, it's going to spin a little bit faster up to its maximum rate. When the mouse moves away, it's going to slow down to its minimum rate. And that animation's just achieved through having a listener on the enter frame event, which is just going to animate that through each successive frame. And if I get the demo up for there, you sort of see this little marker here, spinning slowly. If I hold the mouse over it, it's going to speed up a little bit. Take the mouse away, it's going to slow down. So then I can take that marker and use it inside a map. And initially I'm just sort of showing the code which is used to load an icon image. Very simple change just to load the Flash movie, spinner.swift instead. And in this case I've also chosen to make draggable true so that while it's spinning you retain all that functionality of being able to drag the marker around the map. So if I get this demo up now, you sort of see a map which has got two example objects positioned here, both happily spinning. You can see if I hold the mouse over, that one speeds up independently of the other one, and at the same time it's possible to drag these things and they keep spinning and everything works really as you'd sort of want it to. And we've had demos put together where people have used markers which are video files, and you can drag these around merrily, have multiple ones, all of which while the video is sort of still playing and audio's coming out. So an example somebody might use, so you've got a wildlife park, you could have little flash animations which are the animals running around inside their enclosures. You put the marker over them, maybe you hear the audio recording of that particular animal. So there's the opportunity really to sort of create some quite fancy maps. Info window is one class for which we don't expose the constructor. If you want to put together an info window, you have a choice either to open it on the map, passing in a lat long, or you can open it on a marker where the marker's lat long will be used directly. In both cases, you pass in info window options, which again is one of these classes which lets you do pretty much anything you want to the info window. I say anything that you want. Actually, one feature we don't yet have is the opportunity to pass in a display object in the same way that you would for a marker. So we can't yet allow you to provide sort of fully customized info windows. But that's actually a feature which is so obviously needed that I'm sort of very confident we'll be providing that in the very near future. There's several parameters which affect the geometry, the layout of these. Info windows consist of a title and some content, both of which are optional. Shown in green are some geometry features which set the sort of size of all these things. In red, there's some stroke and fill styles, set what color things appear. And then both the title and the content regions have a number of sort of text formatting things which let you pass in plain text, let you pass in HTML text. If you use HTML, you've got the opportunity to have things like links from that to other web pages. HTML will take preference over the plain text if you specify both. I think one of the sort of most rewarding things of working in the Maps API team is often sort of not seeing what we put together, but seeing some of the things which developers have put together. So just in the sort of final sort of 5 or 10 minutes, I'd like to sort of show a few examples of some of the API sites, some of the demos which we've come across so far. I'll perhaps cheat a little bit and start just with a demo which was provided by an intern, Joe Neiman, in Sydney. So all these display objects are subject to the standard sort of Flash transformations. Joe's taken this map and basically allowed you to spin it. So if I hold down the mouse over the bit in the middle, you can sort of spin that map, and that is a fully functioning map at the same time as it is spinning. So all the sort of usual functionality on the map is still exposed there. Another colleague in the audience has made very careful that the controls are treated differently from the map itself, so you can have the option to spin the map, keep the controls where they are, or sort of vice versa, depending on what it is you need to do. One of the trusted testers just before we had public release was Advanced Flash Components. Some of you may have seen this little demo, which just illustrates how possible it is to how easy it is to combine the sort of Flash video with a map. So it's just sort of showing a little flyover, taking a route across from the States, and in each case sort of showing music playing, sort of showing video at the same time. And just sort of go back, it's possible to sort of do things like put video into markers if that's of interest, and you can really sort of have a lot of stuff which would be difficult to do on the JavaScript API, although certainly some of it is possible. The product manager, Mickey Kataria, got in touch with me last night to tell me about another example. I believe the author may be in the audience, so thank you very much. And if I'm right, I saw a JavaScript version of this at WhereCamp, possibly. Oh, okay. But this little website. Okay. It was either that or I was having some deja vu. It's got some sort of nice panoramic interaction in which you can go to various places, see views of them, and it's combined now with a flash map. So if I zoom in on one of these locations, there'll be a large panoramic image load in the background, and once that's loaded, I'm able to sort of spin around and really sort of seeing some of the integration which developers are putting together between the Maps API and their own work is very rewarding. And then a demo we picked up probably about 3 days after we launched the API is this one, which just sort of shows some of the perhaps more fun things which people can put together. Yeah, that's okay. So once it's loaded, I get an interactive driving game, sort of using the Google Maps API underground. I'm just trying to. Okay, perhaps not immediately correlated with the road, but you're able to. At some point, if we put height in, we might run into a few issues on that. But you perhaps sort of get the feel. Like I say, it's great. It's great to see this stuff coming back. So that's really what I've got to say. There's some further information on a number of these URLs. One which I would perhaps highlight is the groups.google.com in the middle. We've already had a lot of feedback. People have picked up issues. It's been a massive feature requests, and we really do pay quite close attention to that, and we'll endeavour to make sure that all those things are addressed as soon as possible. Just remains for me to say thank you on behalf of the Maps API team for your attention. Appreciate that. I just have been asked to do a little bit of housekeeping. So please do provide feedback for each and all of the sessions you attend. We certainly read that, and we will endeavour to improve things year on year, sort of based on that. Lunch should now be ready. I believe it's been ready since 12, so between 12 and 2, you'll be able to get lunch. That's on the 3rd floor. Okay, so, and the other thing is, if you haven't yet picked up a badge, please do try to get to registration by 2 today. Okay, thank you.